This is lesson 14-3. I want you to try the first three problems on your own. So pause the video and do the first three, but I'll warn you, number 3 should seem a little unfamiliar and a little strange, and you might try to figure a way to solve it, or you might just want to think about it. But pause the video now and try the first 3 problems. All right, so solution to the first problem, we need to identify the segment we're trying to find and the segment that's going to help us find it. And from that angle's point of view, 86 is the opposite. The one we're looking for is the hypotenuse. What connects opposite and hypotenuse? From SOHCAHTOA, we remember that it is the sine. So sine of 57 degrees. A sine, cosine, or tangent always requires an angle as an input. Equals the opposite, 86, over the hypotenuse, which we don't know. The variable's in the denominator. That algebra requires a little extra work. You know, if it makes it easier for you, what you can do is put the left side of this equation over 1, because dividing something by 1 does not change its value at all. Right? And then do something that you may have learned in first year algebra that we oftentimes refer to as cross multiplying, which is different from multiplying straight across, right? If you have two fractions like 1/3 and 5/7, and you are multiplying two fractions, you multiply straight across, numerator times numerator, denominator times denominator. But if you've got two fractions set equal to each other on opposite sides of an equal sign, which is different from what we had here, then you can rearrange that equation in such a way that you have no more fractions anymore. And this can be a useful thing to do when your variable is in the denominator of the fraction. So we multiply the h times the sine of 57 degrees. Now that's diagonally across that we are multiplying. And when we do that, we just get h times sine of 57 degrees. And then when we multiply diagonally that way, 86 times 1 is just 86. And there still has to be an equal sign here. We've got an equal sign there. We still need an equal sign. We should never lose track of the equal sign once we begin with one, right? But we're trying to isolate the h. We're trying to solve for the h. And so since the h is being multiplied by sine of 57, we have to divide both sides by the sine of 57 degrees. And if it's me, I do all of this algebra before I ever reach for a calculator. I don't reach for a calculator until I've isolated the h. Then I reach for the calculator and I put this expression into the calculator like that. And the calculator, if it's in degree mode, will spit out a value of 102.6 when rounded to the nearest tenth. Since that is supposed to be a value for the hypotenuse, that seems reasonable because I know I had to come up with something larger than 86. Number 2, the value of the tangent of angle Q. From SOHCAHTOA, tangent is opposite over adjacent. Tangent of angle Q equals the opposite, which is 12, over the adjacent, which is 5. End of problem. No algebra to do, no button pushing, no nothing. Don't change that 12/5 into a decimal. It's a waste of your time. And then number 3, I warned you, was going to be a little bit different. We're trying to find, it says the measure of angle E. I've not asked you to do that in the previous 2 lessons. And so if you recognized how different the question was, that might have stopped you in your tracks right there. Or maybe not. Maybe you persisted thinking, well, this should be just like the other problems. We're going to need some trig to do it. And from angle E's point of view, 41 is the adjacent, 75 is the hypotenuse. Cosine connects adjacent and hypotenuse. So let's set up a cosine equation. But now right here, you might have started wondering if you were doing this correctly, because what are you going to put in as the input for cosine? We need an angle measure. Well, we don't always need an angle measure, but if we don't have an angle measure, we need something that represents an angle measure. So we could just put in angle E right there. I mean, if you want to, you could invent a little variable for the measure of angle E. any variable you want, call it x, and then say cosine of x, because x now you've invented to represent the measure of the angle. But why invent a variable like x when we already have a name for the angle E? Let's just use the letter that's already there. But I like putting in the angle symbol there, okay, just to sort of reinforce to myself I'm putting an angle in here, something that represents an angle size. And the cosine of angle E is the adjacent over the hypotenuse, which is 41 over 75. But we're not done with the problem here, okay? And maybe you got this far, and maybe now's where you realized you're stuck. Maybe you didn't. Maybe you thought you got the answer. Maybe you thought this wasn't so strange, this wasn't so easy, the answer is 41/75. But no, that's not the answer, because I asked you for the measure of angle E. I didn't ask for the cosine of angle E. I want to know what the measure of angle E equals. By the time we're done doing our work here, we should have an equation that has angle E isolated on one side of the equation. And that's not what we have. This angle E here is not isolated, right? There's a cosine around it. It's sort of like saying this. What if you wanted to solve for x? You had some equation you were working on, and you ended up with this. You haven't solved the equation for x. You haven't isolated the x because there's this square root symbol hanging around that x, and you need to get rid of it somehow. And in that case, you'd want to square both sides of the equation. Yes, I said square both sides. Don't take the square root. You're trying to get rid of a square root. So you would have to square both sides. Why am I not getting? That's so crazy. Squared. That would get rid of the square root, and you'd have x is equal to 256. Well, we don't have a square root, and we don't have multiplication, and we don't have division, or addition, or subtraction. We don't have any familiar thing that we know how to undo. We know how to undo addition. If x plus 6 is equal to 25, we subtract 6 from both sides. Subtraction is the opposite, or what we sometimes say in mathematics, the inverse operation of addition. Inverse because it undoes the other operation. Multiplication and division are inverse operations of each other. One undoes the other. Okay? So we need something that will undo the cosine function. We need some inverse function of cosine. Again, just like subtraction is an inverse function of arithmetic. Okay? Before I show you what that inverse function looks like and how to apply it to the equation, I want to remind you of some things that you've learned along the way and that probably nobody really ever drew your attention to. As you learned these things, teachers just said, do it like this, write it like this, and you followed their lead and you never thought about it. But when we're undoing an operation in equation, okay, we have different ways of showing that we're undoing. For instance, if we had x plus 6 is equal to 12, and we wanted to undo that addition and show somebody what we're doing, right? We have the operation and the value that we're undoing, the minus 6, and we write that negative 6 below the positive 6, only because that's how you've been taught how to show it. And other people are taught different ways of showing that, but that's typically how most of you are shown how to show your work of undoing addition, right? Whereas if we have something like this, 8x is equal to 12, and you want to show the undoing of the multiplication, we put the division bar there, and then the 8 below the division bar. That's different from the minus 6, where the 6 is written alongside the minus, right? And we would do that to the other side, of course. And if we're trying to undo division, let's say x divided by 5 is equal to 30. Well, we've got a couple of options here, but we're going to put a multiplication symbol out to the side of the expression x over 5, and then 5 to the left of that. And then we're going to do the other multiply by 5 on the right side. And probably we would write it out on the left because we wouldn't want to have to try to squeeze it in between the x over 5 and the equal sign, but that would also be an option. Okay, but probably nobody would do this. Well, first of all, let me put that division symbol back. Actually, let me erase this whole thing. Give myself a little bit more room to show you what I want to show you. Again, if we're starting with x over 5 is equal to 30, probably nobody's going to do this. No one's going to write times 5 times 5 like that below the line. Would that be wrong? No, not really. I mean, as long as you carry out that operation correctly and simplify each side correctly, sure, you could do that. Okay? It's just not how you've been taught. And the last example I want to show you is this one's particularly important and relevant to what we're learning today. So pay attention to this one. Suppose we had an x squared is equal to 50. Now, how do we show that we're undoing the squaring? With what symbol? Square root symbol, right? And where are we going to put that symbol? On the left side of the equation and on the right side of the equation. You know where, right? We're going to put it here around the x squared, and we're going to put it here around the 50. It's going on the left side of each side of the equation. It's going to the left of the x squared, to the left of the 50, and it is encompassing the x squared and the x 50. You would not write it like this, right? I mean, that looks like the square root of nothing. And then what? Plus x squared times x squared? That would be confusing looking to anybody who is familiar with square rooting, right? And here's what else you would not do. You would not put a square root to the left of the x squared and cover the x squared, and then put that square root over here to the right of the 50. Again, that would really confuse anybody who knows their algebra. They'd say, what is this over here? What is this? 50 times the square root of emptiness? Right? You would never do that. Okay? You wouldn't put the square root on the left side of the x squared, but on the right side of the 50. Okay? Now, again, going back to multiplication, if we're multiplying both sides of an equation, we can get away with that, right? Because the order of multiplication doesn't matter. So if we have x over 5 is equal to 12, and you want to multiply both sides by 5, you can put 5 times to the left, and then you can put the other times 5 to the right, and you can get away with that. Okay? But when you're square rooting, there is a very particular place and a particular way that you have to draw that square root symbol. Okay? I say all of that. I know you know all of that. You think I'm not teaching anything new here. But I say all that because the way that I've got to show you of undoing this cosine function, there's a way that we write it and there's a place that we write it. And you need to learn how to write this properly. Okay? Not just because I want to see it this way and other teachers want to see it this way, but also mainly really so as not to confuse yourself about what you are actually doing. Okay? So we need an inverse function of cosine. Again, just like subtraction is the inverse of addition, right? The name of the inverse function of cosine is called, this is a brilliant name. You're going to think somebody was so smart for inventing this name. It's called cosine inverse. How about that for a brilliant name? Cosine inverse is the function that undoes cosine, all right? You know, if somebody had called division multiplication inverse, I think that would have been a really smart name instead of why invent a whole new word called division? Or if somebody had called subtraction addition inverse, I think that would have been really smart. Why invent a whole new word like subtraction? So somewhere along the way, some mathematician got smart and said, I'm not going to invent a whole new word for this. Let's just call it cosine inverse. But how do you write it? And where do you write it? Okay. It looks like this. Let me get a different color here. Looks like this. COS, which looks just like cosine, but then it looks like that COS is being raised to the negative first power. That's not really what cosine inverse is, which, in my opinion, is potentially really confusing. I don't like it. I wish the mathematician who invented this had invented a different way of writing this, but we're kind of stuck with it. This is what people all over the math universe write. This is cosine inverse, but cosine inverse is a function which requires an input, just like sine, cosine, and tangent, just like the square root symbol requires an input. So what is the input to the cosine inverse? Well, it's this whole side of the equation, okay? We're taking the cosine inverse of that whole side of the equation because the cosine inverse has the effect of undoing the cosine function and leaving the angle E remaining. Just like, once again, if you're trying to undo squaring, right? This square root symbol undoes the squaring and leaves the x standing, right? And over here, you'd put that into your calculator if you wanted the decimal number, okay? So you have to write cosine, and it's got to look like cosine to the negative first power, and it has to have parentheses, and the parentheses must encompass what it is that you're taking the cosine inverse of, okay? But if we do that on the left side of the equation, we have to do that on the right side of the equation. You have to write cosine inverse of that stuff on the right side of the equation. And I'm going to show you where you better not write it, because this would be confusing, not just to me, but to you. Do not put cosine inverse over here. That's the wrong place to put it. Remember, cosine inverse needs an input. It needs parentheses and something to go inside. So you've left off the parentheses. So let's add the parentheses. Oh, now what are you going to put inside of that? You don't have anything to put inside of that. Okay? You're confused because that's the wrong place to write the cosine inverse. You must write the cosine inverse to the left of this side of the equation. And I don't really have room for it there, so I'm trying to squeeze it in. It looks like I'm writing it above, but I'm not really. I'm just sort of trying to squeeze it in, and that almost looks like CO5 dash or something like that. It's supposed to say cosine to the negative first power is what it looks like. It's not cosine to the negative first. Don't ever say that. We read that out loud as cosine inverse. Okay? Try to squeeze it in front of that fraction. Okay? And maybe you have noticed that you have a cosine inverse button on your calculator, immediately above the cosine button if you're carrying a graphing calculator. So you need to hit the second key and then the cosine button. And then once the calculator puts cosine inverse on the screen for you, type in 41 divided by 75 and close the parentheses, and the calculator will spit out for you the value or the output of cosine inverse of 41/75. And in this case, what it spits out for you is 56.8. Okay? 56.8. Angle E equals 56. I've rounded it, of course, 56.8. This is an angle measure. So this must be in units of degrees. And look at angle E. Does it seem like it's about a 57-degree angle? Yeah, it does. I promised you in the last lesson or two, I'm going to make the pictures look reasonable, okay? I'm not on purpose going to make angle E look less than 45 degrees, but have the measure actually come out to be more than 45 degrees. I mean, from this picture, it certainly looks like E is more than 45 and Z is less than 45, right? So my intention is not to try to fool you in that regard. 56.8 looks like a pretty good answer. Now, before we race on to any more problems, notice the difference between what I asked in question 2 and what I asked in question 3. Because right when we get to this lesson here, the third lesson in this unit, students start getting problem number 2 confused with problem number 3. In number 2, I did not ask for the measure of angle Q. I asked for the tangent of angle Q. And once we wrote an equation that said tangent of angle Q equals this, we were completely finished because we've written here the value of the expression that I asked for. And on a quiz or a test, I'll have students write this, and then, not realizing that they've answered the question, they will undo the tangent there with a tangent inverse. They'll do the tangent inverse on both sides, canceling out the tangent. And then what they're doing is they're finding the measure in degrees of angle Q, which is not what's asked for here. Okay? Whereas in number 3, I did ask for the measure of the angle. Okay? I need an equation that says angle E equals, or I'm not done with the problem. And so when we write the first equation, cosine of angle E equals, clearly we're not done with the problem. Okay? So the next 3 problems I'm going to ask you to do in a row. I'm going to ask you to pause the video when I'm done speaking. Try all 3 problems. In each of these next 3 problems, you're going to have to write out a trig equation with either a sine, a cosine, or a tangent function. Then you're going to have to algebraically undo each of those to find the measure of the angle. And if you've written a sine equation, you need to undo sine with sine inverse. And if you're undoing a cosine, you undo it with cosine inverse. And if you're undoing a tangent, you undo it with tangent inverse. Okay? So for the next 3 problems, 4, 5, and 6, I want you to try to find the measure of angle M in this problem, the measure of angle S in this one, and the measure of angle Z in that one. Time for you to pause the video and try all 3. Go. All right, so if we're trying to find angle M, this is the opposite, this is the hypotenuse, so we need a sine equation. Sine of angle M equals 50 over 61. How do we undo that sine function? With a sine inverse, which you write over on the left and put parentheses around that whole thing. And then I didn't really leave room to get that sine inverse squeezed into the left, but try to squeeze it in there. Okay, the sine inverse cancels out the sine. This you can put in your calculator, and angle M turns out to be, what did I get earlier, 55.1 degrees, which seems reasonable for this diagram. For S, this is the opposite, this is the adjacent. I need a tangent equation this time. The tangent of angle S is equal to 18 over 29. How do you undo a tangent function? With a tangent inverse function. Okay, tangent inverse. Do your best to try to sort of position that a little bit to the left of that 1829's tangent inverse cancels out the tangent, leaving the angle S standing. And this you can put in your calculator. And what did I get earlier for that? Rounding to the nearest tenth, 31.8 degrees. That seems reasonable for this picture. By the way, if you're not carrying a graphing calculator, what you might need to do is put the fraction in first and get a decimal result for the fraction, then take the sine inverse of that. Like if you hit the sine inverse button on your non-graphing calculator and it doesn't throw a parentheses up, like it just like automatically kicks out some sort of value, okay, that kind of a calculator wants you to know what the input is first and have the input on the screen of your calculator before you press the sine inverse button. So you would want to do 50 divided by 61, get a result, which would be something around 0.8, 56 is 0.83 repeating. So it would be about 0.83. Then when you've got that number in your calculator window, then press the sine inverse button. And again, if your calculator is in degree mode, it should give you the value 55.1. Okay. The last one, since we have all three sides of this triangle, you have the option of writing a sine equation, a cosine equation, or a tangent equation. None of them are easier or less easy than the other. None of them are faster than the other. It really doesn't matter. So I'm just going to set up a sine equation. Here's the opposite. Here's the hypotenuse. So sine of angle Z is equal to 8 over 17. And then when you take the inverse sine of both sides, that cancels out the sine, leaves the angle Z standing. And when you put this in your calculator, I got earlier 28.1 degrees, which seems reasonable for this picture. Okay. All right. Well, if you just had a whole page of these to do for homework, this would get really easy, really fast. And you'd think, why did he give us so many of these kinds of problems? I've learned how to do this. This is easy. Okay. But that's not what the homework is like tonight. The homework tonight is a constant mix of problems like 1 and 2 and 3, some of which where you're having to find a side length, some of which you're having to find the angle measure, and other problems in which I'm not asking you to find a side length or an angle measure, but just the output of a sine, cosine, or tangent function. And again, every year I teach this, I see students, getting a little sometimes hesitant and sometimes more than hesitant, but outright confused as to, wait a minute, what am I supposed to do here? And how do I know that I'm done with the problem? Okay, that's what the homework is like tonight. What I'm asking you for from problem to problem is going to keep changing. It's going to keep changing. So it's going to keep you on your toes and really help you to learn what needs to be done here, right? And that's what these 4 problems down at the bottom are. There's nothing new to be learned here in these 4 problems. They're just problems that I would ask you to practice in class before I sent you out with the homework to do. Pause the video one more time and try these last 4 problems. All right, so in number 7, the value of cosine of angle Q, I'm not asking for a side length or an angle measure. Cosine is equal to adjacent over hypotenuse. The adjacent to angle Q is the 9. The hypotenuse is 41. End of problem. Okay, that is the value of the cosine of angle Q. Done. The measure of angle A. All right, well, let's see. We've got an opposite, we've got an adjacent. Tangent is what connects opposite and adjacent. Tangent of angle A is equal to the opposite 19 over 26. By the way, over here I could have written cosine of angle Q is equal to 9 over 41. Okay. But again, I'd be done with the problem in number 7 because I asked for the cosine of angle Q, which is exactly what's written down here. Here's where students get confused. They'll write an equation like this, and then they'll go, oh, I got to take the cosine inverse of both sides because they're not comfortable with leaving this side of the equation with that cosine surrounding the angle Q. They're just not used to that. They're used to all of their equations not being done until one side of the equation is nothing but a variable. See, and over here, we got to stop with cosine of angle Q. And Students are just not used to that yet. You'll get more used to it over time. But right now, that's kind of a new thing to stop there, right? There's this urge to get rid of the cosine, but don't. Over here, we want to get rid of the tangent because I did not ask for tangent of angle A. I asked for angle A alone. What is that? And that's why in this case, we need to do a tangent inverse. On both sides, as usual. Tangent inverse cancels the tan. It doesn't cancel the A, right? The A remains standing. You put that in your calculator, and what did I get earlier? 36.2 degrees. Okay. Length of EG. So we're looking for that side. We know that side from this angle's point of view. That's the opposite. That's the hypotenuse. So sine is what connects opposite and hypotenuse. Sine of 41 degrees is equal to the opposite divided by the hypotenuse, which is 67. Solving that's really easy. For O, multiply both sides by 67, and opposite equals, that's not a zero, that's opposite side, or the length of EG is equal to, if we round to the nearest tenth, it actually rounds to the number 44.0. And finally, find the measure of angle F. Let's see, this is the adjacent, this is the hypotenuse, it's cosine that connects them. Cosine of angle F is equal to 33 over 36. Now, wait, do we get rid of that cosine or do we leave it like that? Are we done with this problem? Because we could be done. Sometimes this is as far as we go. Are we done? No, in this case, we're not done because it didn't say find cosine of angle F like I did up here, in which case we were done as soon as we wrote the equation. I asked for angle F all alone by itself. And right now, it's not by itself. We need to isolate it by undoing the cosine with cosine inverse. Okay. Put that cosine inverse in your calculator. You should get 23.6 degrees. There you are. Most of the homework is going to be straightforward in the sense that it's going to be these kinds of problems mixed up. Okay. But then on the back page, I think you're going to have to think a little bit. There might be another angle of elevation, an angle depression problem from the last lesson. And the last problem is definitely a little bit different. Read the problem carefully. Read it carefully. Read what it's telling you, okay, about what you're allowed to do to solve the problem and what you are not allowed to do. That's all I'm going to say about it. All right. Take care. See ya.